We are into the last part of the preparation of haloarenes. Till the last class, we were doing the preparation of haloarenes from diazonium salts. We are into the last part. So, the first we will do today is Gattermann reaction. Gattermann's reaction we'll do. So, in Gattermann's reaction, we are having two types of reaction basically, let me tell you. We are having Gattermann's reaction and Sandmeyer's reaction. The difference is that in both the cases we are using the same thing. We will be using a diazonium salt, that is benzene diazonium chloride N2 plus Cl minus. In case of Gattermann reaction, you will be using Cu and HCl. Got it? And in case of Sandmeyer's reaction, what we'll do is that we'll be using same thing, that is a diazonium salt, and here you will be using CuCl and HCl. CuCl and HCl, that's the difference. So here what I am going to get it? I am going to get here, that is nothing but chlorobenzene plus nitrogen. Remember it, we are doing the preparation of chlorobenzene in the last part. So here what I am going to get it? Same thing I am going to get it, that is chlorobenzene plus nitrogen. Okay. Now here I think you have understood now. So in Gattermann reaction, Cu and HCl is being used, and this chlorine, actually this particular chlorine, it comes to as a what you can say, the substituent, or it gets attached to the nucleus of the benzene ring. We can say this particular chlorine from the halogen acids, remember it. And in case of Sandmeyer's reaction, that is the chlorine which is attached in the copper, in this copper salt, that particular halogen gets attached to the benzene ring. So what I mean to say here is that, now this you have understood. Now what I mean to say here is that if I replace this with CuBr and HBr, what I am going to get it? I am going to get here, that is nothing but bromobenzene plus nitrogen plus Cl minus, this particular one, bromobenzene plus nitrogen. So in case of Sandmeyer's reaction, the halogen which gets attached to the benzene ring, it comes from the copper salt, and in case of Gattermann's reaction, the halogen which gets attached to the benzene ring comes from the halogen acid. So this is your Gattermann's reaction and Sandmeyer's reaction by which you can prepare, that is your aryl halides. Next we will come to, that is the next reaction we are going to come to is your Hans-Diecker reaction, which you have already done in the alkyl halides. Here also same thing, I am going to take it. Rather I am going to take benzene ring COOAG, a silver salt, that is silver benzoate. I can say that. Silver benzoate. Now when I will be heating this particular one with Br2 in presence of CCl4 reflux, what I am going to get? Same thing I am going to get it is bromobenzene plus AgBr plus CO2. That is bromobenzene plus AgBr plus CO2, you are going to get it. Okay. So in this way you are going to get it, that is your Hans-Diecker reaction. We can say that from Hans-Diecker reaction we can prepare it. Similarly, we are also having another process, that is your Rasjik's process. It is an industrial method for the preparation of aryl halides. Let me say it is an industrial method. Here what we are doing, we are taking benzene. Alright, we are taking benzene here, plus we are taking HCl, which is in the gaseous state, remember it. Plus we are taking oxygen. Now oxygen from where we are getting it? From air we are getting this oxygen. This means these two are gaseous. And here we are taking CuCl2, which acts as a catalyst, and the temperature is around 500 Kelvin, or we may write simply heated. Now what I am going to get it? I am going to get here is nothing but chlorobenzene. Alright, now if you take here half a molecule of oxygen, if I am going to take it, half a molecule of oxygen, if I am going to take it, then what I am going to get is that I am going to get it, that is nothing but water, because one hydrogen is being released from here, this hydrogen plus this hydrogen, and here half a molecule of oxygen I have taken it. what I'm going to get is water. Or you can take here 2. If you balance it, you will say no, I will not take half. Then you can take here 2 benzene ring plus 2 HCl plus O2 will give you 2 chlorobenzene plus water you will be getting it. So this is your Ras-Gigs process. In the Ras-Gigs process, we are manufacturing, that is aryl halides in this particular way, we can say that. Okay. Next, after that, we will see it. We have already done that. Now here just I am asking you what is the product you will be getting it. That is, I'll take here toluene. I'll take here toluene plus SO2Cl2. Can I tell me the name of SO2Cl2? It is sulfuryl chloride. Sulfuryl chloride. If anybody has said, you are absolutely correct. It is sulfuryl chloride. And here I will be taking 475 Kelvin HNu and little peroxide. Little peroxide. So from this you can understand it that I am going to go for, that is nothing but, what is that? Is it a side chain reaction? I am going to go for it, or whether I am going to go for the nuclear reaction. That means I want to say you that this chlorine will be replaced, what you can say is chlorine will replace one hydrogen atom, or chlorine will be added in the ortho or in the para position. What do you say? HNu and peroxide. Come on. What do you say? HNu and peroxide. So it is going to go a free radical substitution reaction. A free radical substitution reaction is going to go. So hence here hydrogen atom will be, what you can say, chlorine will replace the hydrogen atom. So hence what I am going to get it, CH2Cl plus SO2 plus HCl. This we have done it in alkyl halides, this particular one. This I did it in aryl halides. Now one more. Now here I am taking CH2CH3 and in presence of NBS. What is NBS? NBS is N-bromosuccinimide. If you remember it, this is the structure. This is N-bromosuccinimide. If you remember it, this is the structure of N-bromosuccinimide. Alright, that is succinic acid is CH2COOH. Single bond CH2COH. I have replaced both the OH and instead of that I have put it NBr. So it is N-bromosuccinimide. Okay, that is NBS. We have done this particular reaction NBS. With propene, you have done it in alkyl halides. That is same thing, HNu and little peroxide. So what sort of reaction? Same thing. I think you can guess it. What sort of reaction? That is CH, Br, single bond, CH3. Here H is replaced by the bromine, you have seen it. That is NBS. From the NBS the bromine comes and the H, it is being replaced. Alright, now what I am going to get it? The secondary product, that I am not interested in the secondary product. The secondary product will be CH2COONH, CH2COONH. That is succinimide, you will be going to get it. That's okay, fine. So this is what you can say the reactions. So this sort of question you will be getting it. In alkyl halides we have done this particular one. I have given you in aryl halides. So this sort of question you will be getting it. So these are the preparations of alkyl halides and aryl halides. Next we are going to start the properties. Thank you.